Amazon EC2 basically. So if you remember, we've talked about IAM, which is more or less like it's what gives you access to your account, right? We've talked about the ways for us to access our services, and now we're looking at one of the core services in AWS, and it's called EC2, Elastic Compute Cloud. Okay, um, and one thing you'll notice is that I wrote it here, the foundation of AWS compute. So, like I said, if you remember when I was introducing you and I was saying that I was telling you about why people move to the cloud, right? And I told you that traditionally there was still the concept of a server, right? But now when you move to the cloud, the server is still there. The server is still there. Okay, it's not like the server. It's not like the server is still there. It's just that you've transitioned it from being a physical device to a virtual device, right? And that is honestly the EC2 we are talking about. It's like that compute that you see. So all those physical servers that you used to have on your on-premise or your physical location, it's there. It's there in the cloud, basically. And in AWS, it is called EC2. So what it means is that you find out as time goes on, but it's really like the foundation of everything compute, like everything compute. Even many of the higher level compute are built on top of EC2. Okay, remember that sometimes it's just like a level of abstraction that is added, right? But you can also own the compute yourself. But there are probably other things that AWS builds on top of the compute to abstract some layers away from you. Okay, so what are we going to learn? We're going to learn about EC2 and when to use it, understand the components involved in launching an EC2 instance, identify and compare EC2 instance family types. Obviously, we'll not be able to cover everything, but at least we'll cover the things that we are set out to cover today. So we'll also be able to differentiate the EC2 storage options that are out there. We'll see how you can actually gain access to your EC2 machine, right? And then how we also choose like a pricing model, right, that fits to our workload requirements, and then interpret security group, their behavior, and the rules that applies when you are using like a security group. Okay, and then we'll always see like the shared responsibility model. It's always there. Like every service, there is your role, and there's a role for AWS. Okay, um, so what is EC2 basically itself? And honestly, like I say, there is a lot of things. So if you look at the certification, there are some things it's not going to ask you. There are, like I always tell people, like it's not going to ask you some very, very fine-grained questions like, if I was to do this, which particular instance am I going to do? Nobody will ask all that because those things are things that are continuously evolved, like it continues to evolve, right? So it means there will never be a static list, okay? But one thing you should basically know about EC2 is the fact that it's like you can rent a server. If you followed me on this journey from the beginning, I told you that physically, like when you were like in a traditional setup, there was a server, right? Now in the cloud, you can basically rent two servers, right? And the beauty of it is the fact that you can resize it. So one beauty that you can get from the cloud is the fact that these devices are not fixed. They are devices that you can resize. So you can choose your amount of CPU, your amount of storage, your amount of everything. Like you can basically configure it like to suit whatever you had traditionally. So if on premise, probably before you move to the cloud, you had a machine that was one CPU, 4 gig of RAM. Once you move to AWS, you still can get that exact machine or even better, right? And again, think about it. Maybe on premise, you had like Windows operating system that you're using, or you had Linux, or you had Ubuntu, whatever that was, right? You still can reproduce that in the cloud. That's the flexibility the cloud is giving you. The fact that these servers are there, you can configure it exactly how you want, whether in terms of the OS or in terms of the capacity, right? Again, it's pay as you go, basically. So it means that if you don't, more or less, like if you don't use EC2 machine, you're not going to pay, right? You only get billed when you start using, right? And then you can still scale horizontally, which means you can. So don't worry. As time goes on, as you go deeper in your journey, you begin to understand what is horizontal scaling versus vertical scaling. Because throughout your journey, there's no way you will not interact with both. So vertical scaling is vertical means you are scaling up. So something was one CPU, you increase it to 4 CPU, for example. You scale up, so that's vertical. Horizontal is there is one machine, and then you're adding more. So that's like scaling horizontally. You find out as we go, and then obviously the EC2 machine itself is something that integrates with a lot of services out there. So if you wanted it to be tied to a particular VPC, why not? If you wanted it to be able to do call, remember we've treated the part where one service can talk to other service. So EC2 here is a service inside of AWS, and it means that being a service in AWS, it should also be able to talk to other services, right? And that's where things like VPC comes in, because you can say I only want you to be able to talk to the things that are in this VPC, right? And then you can also say, only if you have this permission can you do this within this account, right? So you can say, if you're ever in this EC2 machine, you can only talk to this service because you have the right permission, right? And then we'll see what Elastic Block Store is, more or less like a storage behind EC2, right? That you can have. And then auto scaling is not something we'll deal with now, but it's something that you have to, you see it as part of the journey. There's more or less like we'll get there. But auto scaling, really, EC2 is like one of the backbones behind auto scaling, right? The fact that you can request more machines. We've talked about compute here, but most times I don't think you need one compute to do what you're doing, right? Most times you start with one compute, and there are sometimes you need more compute, and then you can ask for more, right? So let's now look at the components. What are the components that makes up like the EC2 that we're talking about? Remember, we said it's a virtual server, right? A server that you don't see, but it's somewhere. Okay. So what are the components that makes it up? And this is important for you to know how an EC2 machine or a server is formed. First of all, there's the concept of a Amazon machine image, and you see it popularly called AMI. So AMI is just basically it's like the OS, the OS, right, that runs the EC2, that is run on the EC2 machine. So what it means is that it's just like traditionally you had a machine, and in that machine it wasn't a black box. It had like an operating system, right? So maybe it was Windows, maybe it was OS. That's how it is also in AWS. There is when you are setting up a server, one of the core things you have to give it is which OS is it going to run, okay? And honestly, AWS doesn't restrict you. There are so many OS you can try. One of the popular ones is really Amazon Linux, right? Amazon Linux 2. But right now we've shifted a lot of applications to even use Amazon Linux 2023. But there's also Ubuntu, there is also Windows, and there's even third-party operating systems that you can get. So what I mean is that let's think about somebody who has like a service is producing, and they built that into a particular OS. They can give you that AMI, they can distribute that AMI to you, and once you install that AMI on the machine, it means you are getting the third-party service already. Okay, so there's always the Amazon images, there are public images, and there are images that maybe you are dealing with a third party that's providing a particular service, they can give you. And Jay is also mentioning CentOS, Red Hat. There's so many, the list is endless. Okay, so many OS that is out there that you can use, but they all come together, and you call it, the single word for you to call it is really AMI, which is Amazon machine image. So it's like a machine, it's like the image that powers the server, right? Like I also said, the sources, there's AWS provided, right? So for the most part, most of my experience, we use the AWS provided, but there is also like marketplace for you to get a particular AMI. I've used that also. Like there was one time we didn't want to install our own Sentry instance, and we needed to use like a marketplace AMI, and then we got that. Although at some point we built our own, but that's where custom AMI comes in, right? Because as opposed to using AWS own or using one from the marketplace, you can build your own. Okay. AMIs are region specific. Take note of that. What it means is that a particular AMI machine image is tied to a region. So if you ever wanted to use it in a different region, you have to copy it over, right? You copy it to the other region and then use it there. Okay. So what other component makes up like a server? So another thing you should think about is that usually a server, like a server, an EC2 server will have like an instance type, okay? And the instance type itself is a mix of many things, okay? Because that's really what tells you it's like a broader category. So when I say instance type, it's a broader category that tells you the CPU, the RAM, the networking requirements, okay? And these things, honestly, like I always also mention, you don't need to put them in your head. There's like a comprehensive list of all the EC2 instance types that AWS has. So it's not a list you should put in your head, but just know that there is like there's like an umbrella, which is called instance types, right? But that instance type is usually it's like a broader definition, but behind it, it's just telling you that this particular instance type has this amount of CPU, it has this amount of RAM, it has this network, it has it gives you like the capacity, the network wise also, and usually it comes with a pattern of family. So which family does it belong to? There is a generation that follows, and then there's like a size. So the family is usually something like M5, right? So it tells you usually when you say something is like a family, it means is it memory optimized, for example? Is it compute optimized? There's like there's like a family, they name it. So it's family dot generation dot size. That's like the standard way of calling it. So it starts with the family. So which family does this instance belong? Is it like something that you use for memory intensive work or something that is used for compute intensive work? And then within that is usually what they call generation. Generation is just like the advancement, right? Remember, I think if you check my post, you see where I think I recently did, like there was a post out there that showed you, how you could leverage more like more recent EC2 machines, even at cheaper cost. What it means is that generation 2 could be something that was released in 2020, right? But generation 7 could be something that is released in 2024, right? So it means that it's a way for them to also track. So within the same family, there'll be different generations, right? So it means this is memory optimized, but we released this machine 2020. But now this is also memory optimized, but we released it just 2023. So you see that. Then at the end is now like the size. So how big is the machine? And you'll be seeing things like X large, 2X large, 4X large, 8X large, all that. It just tells you, how powerful or how big. And the size also influences things like how many CPU, how many RAM, how much is the network capacity, and then you see that. So, and then AWS have also started doing their own kind of processors, right? They call it the Graviton processors, okay? It's usually suffix G. So whenever you see it, honestly, it's not something you need to put in your, like I always mention. So when you go in there and you're trying to set up an instance, there are places where you can use the ARM instance types, okay? It usually has a suffix of G. So G would always be part of the name, and that's how you recognize that this is a Graviton instance, okay? So like I mentioned, there is like an AMI. AMI is just like the OS that is powering the server, right? The machine in this case. But again, Instance type is a group of many things. So more or less like the CPU, it's like the property, it's like a large, like more or less like a broad description of the properties of the machine. So CPU, RAM, and all those other good stuff. So when you look at it and I'll mention it in this call, you don't really need to. These are things you don't really need to cram, right? There is like a documentation out there, and these things keeps changing. Okay, so general purpose basically. So how do I, if I want to use EC2 for example, this is me talking to you practically. Usually, most people start general purpose. So let's assume I have a workload that is already on premise, and I wanted to switch to the cloud to use it. I usually will start general purpose, especially if I'm not sure of exactly how much memory or how much RAM I need. Most people just start with general purpose, and then from there you can migrate the machine to something else. But usually general purpose is just like there's a balance, right? Balance between CPU and RAM and networking. So there's that balance. There's not like one is more than the other. There's like a balance, okay? And the use case, there's so many use cases out there, but usually it's like when you want to test something, you're not really sure of how much your server is going to require over time, right? You just want to experiment. You can throw a general purpose at it. And then when you monitor it, you can now begin to see, oh, it's like it's using more CPU than RAM. Maybe you need like a CPU optimized instance, or maybe you need like a RAM optimized instance, okay? So, and there's like a free tier, we'll see T3 micro, which is like the T2 micros, the T3 micros that we're going to be using on this call is free tier, 750 hours for the first year, honestly. So for when we run those instances, if you run one completely throughout the year, it's going to be free, and it is really what we're going to be using for most of our demos, so that we don't spend any money. Okay. Um, I just put an analogy there, but basically it's just like something that you use daily. It's not like something that is customized for a particular use. It's just like you don't, it can handle many of the cases you have. It's not specialized. Okay. So I'll go through the first slides that talks about the instance type. Then we'll go to the AWS documentation itself, so that you see the instance type. And like I mentioned, it's not a list you should put in your head like, oh, this is it. No, because when you're faced with a challenge as part of your growth, usually we'll go to the instance type from the documentation and pick one that suits your unique case. Okay, and that's why I said for general purpose, people usually start from general purpose and be like, okay, I'm not entirely sure how much memory I'm going to need as time goes on, or RAM. So let me just use general purpose. And then that's why there's metrics. You can begin to monitor it, and over time you can begin to see, I think my application is actually CPU intensive, and that can help you switch to something that is more suited for like a CPU intensive workload. Okay, so and in this family, that's where you see like the T3 instance, and then the M instances. But one thing you should understand is that honestly, these things, they're just there's so many instances out there. There is usually one that is going to solve your needs as time goes on. Okay. Um, what about compute optimized? When you hear the word compute, now take note. General purpose that I just mentioned is general. It's really general. It's not specific. It's not specific to a particular use case. It's basically usually you want to test, you want to build something. Usually it's good to start with the general purpose, right? But when you now know that your workload, or even before migrating to the cloud, if you know your workload is compute intensive, right? Compute is just CPU intensive. That's the way I put it. Okay, it means that there is more CPU now. So there are instances that can give you more CPU than the memory. So and they are well suited for things that are compute heavy. So if you wanted to do like real time, bidding like ML inference on CPU, those things they consume a lot of your CPU, right? That's where a compute optimized instance will work, right? So like batch processing, media encoding, gaming servers. Honestly, if you see this thing in certifications, also the answers are usually very clear. It will tell you the person needs to more or less like do computation. There is more. It will hint you to tell you that the person wants to choose something that is more compute heavy, right? So that's like a good time to know that you're going to be needing a compute optimized instance. Okay. If you see like a sport bike, right? Basically, you're using it for sporting, so you need to run very fast, like fast focus. That's one way you can use like a compute optimized. We'll go back to this list, okay? But these definitions are also inside of AWS, okay? And it's not something you can miss. We'll go back to like the documentation itself. So if you know something is compute optimized, there's also memory optimized, meaning it's more intensive for memory, right? There are a lot of databases that uses that are kind of very, very heavy on memory, right? If you look at Redis is like in-memory database. It requires a lot of memory because it's trying to process so many data at once, right? So it needs a huge memory to keep reference of that data, right? So yeah, I don't need you to put the families in your head. This snapshot is just there so that there's like the R family, right? So many kind of machines. You can go as low as 4 GB up till like 20, like 16, 32, 64, 128 GB, as time goes on. So there's a lot. And there I said like a giant whiteboard of data, right? A very giant whiteboard of data that you need to keep track of because you're looking at the data at once, right? And that's why it's like memory. It's just like you as a human being, you're trying to fit so many things at once. You need, more or less like something that can, keep track of that at a go. And that's where memory optimized instances, that's where they come in. Okay, so large RAM per vCPU memory. So when you think about it, usually memory optimized will trade more RAM for this versus the CPU, and compute optimized will also trade more CPU for the RAM. Okay, But these things are usually not something like I don't know why I always like to mention it, but it's not something you need to put. It's just for you to know that it's your workload that will determine. So whatever you're trying to put or whatever you're trying to build is what will determine, which side will you tilt to. Will you tilt to compute or will you tilt to memory? Okay. And then there's also storage. Really, storage is basically is different. It's not. It's more or less like there's like these IOPS, like right. So input output is happening at a fast rate. Okay, so it has to do with file. We are reading very very fast. You are reading the file system very very fast. So when you need to that's strong access to files. Yeah, that's where like a storage optimized instance comes in. And the definition is also given to us by AWS. We'll see it. There is like well-known families that are out there. Use cases where no SQL obviously because you are reading the database, like there's DB, there's data, and there's a lot of reading and writing that is going on in there, right? Log processing, data lakes, all that are things that tells you that you need more or less like a storage optimized. Okay. um so and then like there are some simple analogy that I did put there. So I'm not going to let me just quickly show you so if I go here, I'm just trying to tell you that although I didn't mention all of them, but I don't really need to mention all of them because nobody will expect you to put them in your head in the exam, right? It's so many of them. Okay, so even if you go to the AWS documentation, it's clearly stated there. And there is a way I'm teaching you these things. I'm telling you that as much as I'm telling you what you need to know, ultimately yes, you don't really need to memorize anything. Trust me. That's why there's a documentation for you. Nobody memorizes these things. I do not memorize these things. I don't really need to. But you just need to know the what is on the left is what you need to know and what they are for. Okay. General purpose. What is general purpose? Compute optimized. But you don't really need to know the specifics. No, none of the exams will test you to tell you M5A. Nobody will tell you that. You're not a robot to know all these things. Okay. But it's here. So if you ever want to go deeper, and I expect you to do. Okay. So after this class or in your own research, you can go to just type EC2 instance types. It will bring you here. You can see them yourself. So it's not hidden information. It's out there. And these things, they keep changing. And it's the more reason why you have to keep going there, right? So general purpose is here. You can always see what it looks like. Compute optimized, you can see. And the good thing about it is that when you click on any of them, it tells you exactly, so it tells you, like if you see M7, M8 tells you that it's more recent, right? So if you see them, you see T2 is here at the bottom, but it's now M8. M8 is like the most recent, right? And there are benefits you get from using M8 as opposed to T2. Okay, so you can go there, check exactly. The good thing is that you move across these families, you can always see what it takes. So this will tell you you need 2 CPU, 8 GB of RAM. It's EBS only. It tells you the bandwidth, the network speed. It also tells you the EBS bandwidth also. So all these things are here just so that you know that I can't put this in a slide. There can't be a slide that'll cover all these things. Always rely on the AWS documentation. If you go to compute optimize, they are ideal for compute bound application. So if you go to the certification and you see anything compute related, right, it tells you need a compute optimized instance, right? So, and you can also see the examples that are here, and it's here also. Yeah, if you want to, you notice is that for compute optimized, you can begin to see, you can also get things like 16 CPU, 32 CPU. These are huge machines. They are not small machines, right? You can see you are getting 32 CPU against 64 GB of RAM, right? So you're getting more CPU to RAM ratio. And then for memory optimized, the reverse is almost the same. You see machines up to 384 GB of RAM. I know most of your experience, you probably in your local machine, you have like 16 GB, right? But in the cloud, you can really get powerful machines. So if you scroll down this list, you're like getting up to a terabyte of RAM, right? So you can imagine what you want to be running in those kind of machines. But that's the power of the cloud. Okay. I did mention some. There's also accelerated computing. You can always go find them out. There's storage optimized. We can't cover this list, trust me. But I'm telling you this just so you know. I'm not the only reference you should be using as part of this training. This information are public information. You probably need to also go there, play around it, understand what it does, and all that. So that's obviously. Remember, we're still looking at the things that tells you about it, like the components in the server, right? We've talked about the instance type. What about storage? There's usually, think about it, there's no compute most times that doesn't have a storage. It's not possible. There must be like a storage. Okay, there must be like a storage. In our own case, like in your laptop, for example, or your server, right? There's usually like a storage. There's like a hard drive, right? It's just that in the case of the cloud, the hard drive is usually like a network device. It's also a virtual device. So what it means is that at the end of the day, compute is treated differently. Storage is treated differently. Okay, and it means that both can scale in isolation. What it means is that storage can scale up on its own. Compute can also scale up on its own. But what are the storage options? EBS is the really common one that is out there. There's like a whole section that we're going to talk about EBS, but I'm just telling you the things you need, right, for a server, for a particular server, and storage is one of it. So EBS is like a persistent block storage. Instant store is like a storage that is attached to the machine, right? It's a storage that is attached, but it's ephemeral, meaning if you stop the machine, right, you're going to lose the data. Okay, so what it means is that it's like a hardware device that is attached to the machine. And basically, it's just like if you are using it, it's more or less like for cache data. You're just like maybe you want to process data that is in that machine, and it's like maybe like cache data and all that. Something that you don't really care about if you lose it if the machine has to restart. Okay, and that's where EBS comes in, because EBS is persistent, meaning even if you stop the machine, the data is still going to be there. If you terminate the machine, in as much you didn't delete the volume, the data is going to be there. So you need to understand. But don't worry, there's specialized sections for these things, because EBS on its own is a topic, right? EFS on its own is a topic. So, and then EFS is like elastic file store. It's like a shared file system basically. So you can have many machines use one file system, right? Such that if you store, someone another machine can always also read it from somewhere else. Okay. Let me see what other options. Okay, I think with that's fine. I just wanted to show you more or less like the core components of like an EC2 machine. Okay, so the next thing would now be for us to create like our first EC2 machine, the first one we want to create on this call. So um, I think I have not even sure where that detail is. Let me just quickly find it. There's something that I think I stored somewhere, but it's not here. I just need to get that out. But I need to bring that from somewhere else so that, just give me a second. So we are going to be creating our first EC2 machine. While we are creating it, we'll now be looking at some of the components that we've already talked about. Okay, so let me see. And I'll show you the things that are the most important that you need to care about. So just give me a second. Okay, I think it's this one. I don't need this. Usually there are questions, but I don't usually answer questions now till I'm done with the class so that I don't digress. Okay. So if you if you stay till the end, probably will see me answer questions. Where is this? Okay. My screen is kind of Windows is really. I don't know why we don't have TikTok for Mac. Honestly, for some of us who are not really like very Windows heavy users, we're just. But it's fine. We'll get along with it. Let's see. Just trying to clean up this. All right, so let's go. Let's demo something. So just going to share. Where is it now? Going back to my account. All right, so I'm back to my account. So this is what I wanted to share. So I'm back to my account. So what you see here, like I always mention, right now, this is my root user. But I also have my other user logged in. Okay, so like I said, most of the things that I'm going to be doing, I usually like to do use my non-root user. Okay, and it's there, it's there on purpose. Okay, so let's try and create EC2. So like I said, let's go back. If I go here and I type. Maybe luckily that one showed up because I've already had it. But ideally, if you wanted to create a brand new one from your own environment, all you just need to do is search. We've said it. That's like the fastest way to get to any service. So you search. It's here. Basically, create, manage, monitor virtual servers in the cloud. As simple as it is. Honestly, there's a lot of advanced stuff that goes in here. But trust me, you're at the beginning. You don't need to pay attention to many of the advanced stuff. Build your way up, okay? But honestly, EC2 does so many things. So many things. Like basically anything compute, anything around compute is what you would pretty much answer with EC2. Okay. So what are we going to be doing? We're going to be launching our first EC2 instance. Usually, so I need to take note of my region. I'm in US West 2, right? So I'm just going to call it my web server, right? Let me just call it my web server. There is a name there already. So web server. Good. Now, if you remember, I told you the components that is needed for you to have like an EC2 machine, right? So one of it is really the Amazon machine image, which means that which OS is going to power your machine, okay? So in this case, you see there's a lot of AMIs there, and you can also browse even for more, okay? But for this demo, we're going to use the Amazon Linux, which is like the one that AWS ships for us, right, within the account. So there's also Mac OS, Ubuntu, Windows, Red Hat. Trust me, the liter over there, like there's so many. Here it's saying we should use free tier. So free tier, there are really two free tier eligible. Amazon Linux 2023 is the new one, right? There's a lot of things that have changed in 2023. So I'll still stick to the Linux 2, okay, like the L2, right? And actually, what am I looking at? I'm looking at the ones that are free tier enabled, okay? Because you can see free tier eligible, right? So these two are free tier, meaning you can always use them free tier. It covers your free tier use case, okay? Here, I'm not going to change the architecture. I'll leave it as 64-bit x86. Now, remember I also told you like instance type, right? Instance type is like a larger grouping that tells you, in fact, it's where we left off just now, right? We went and we checked all the instance types that were there. And I told you it's like a very long list. You don't need to put it in your head, all right? Just know that there is a place you can always make reference. I also make reference every day if I want to see what are the instance types that are out there, okay? But one thing you should know is that when you click on this list, there is like a whole lot of instance. And you can also search if you had like a specific instance you were looking for, you can type it here. But I'll just be looking for the ones that are free tier enabled, right? So here there is like a T2 Nano, and there is like a T2. So there's a T2 micro, and I can see it is free tier eligible, right? T3 small, T2 small is not. So I'm just going to go with the one that is free tier eligible. So I'm just going to pick this one. So it's like a T2 micro. I think it was selected for me already because there is it's free, it's basically free tier, and you can see all the hours that it's charged for. So here I want to create a key pair, and I'll show you what a key pair is. So I'll say my web server, my web server, basically. So it's RSA, it's a PEM file. .ppk, we'll find out what .ppk is, but if you were really dealing with things, Windows less than Windows 10, but I think I've asked also the people who are following me on this journey, most people use Windows 10. Honestly, you should always use like more recent things change every day, right? Why are you still using like very old OS when you can use like new ones? Okay, so we'll be using PEM. I'm just going to create, it's my web server PEM. I'm going to create the key pair. It's created, it's downloaded already on my file. Right now I won't talk about the networking part. Okay, we'll get there as time goes on, but right now I'll just leave everything almost like default. Right now I'm allowing SSH from everywhere, and then I'm also, because yeah, it's not, I don't really need to care about the HTTPS traffic. And if you remember, if you go to some website, so because I'm talking to beginners, what you should know is that if I go to google.com, right? Google.com, if I try to copy this URL and I paste it, you can see in the URL there's HTTPS. It's just a secure traffic, right? A secure endpoint for you to reach. But have you ever thought about if I put HTTP? So if HTTP is different, it's different from HTTPS. So if I put HTTP as google.com, it still opens google.com, but I think it just redirected us. So if you notice, I put HTTP here, just so you know, but it did change it to HTTPS. Okay, that's just the difference. So some websites, usually most websites you can access most websites using HTTPS. Okay, but that's what it means. You do these things, but you don't notice. Most of the sites you go to, you are accessing them via like a secure endpoint, right? So we're still here, so we're just going to allow traffic from the internet. This is bad practice. What I'm doing right now is just for the demo, right? Ideally, you don't open like say EC2, everyone from around the world should be able to access it, right? But for my demo, I'm just going to show you what it looks like. Okay. For now, I don't really need to care because free tier, I can get up to 30 GB. Remember when we started, I told you what free tier is, what are the things you need to know. So here, yeah, I'm just going to go with the default because it's covered on that free tier. So GP2 or GP3, I'm just going to leave that there. And then there are really advanced properties. So let me see one of the advanced property. Let's see. No need to join the domain instance. Like I said, depending on your level, some of these things begin to become more important. But for now, just follow. Okay. So domain, I don't really need to join. All these are basic things I don't need to care about. There are really hibernate things here that I don't need to care about. Purchasing option, I don't, capacity reservation, I don't need to care about that for now. Tenancy, RAM, disk ID, all that options, I can let them go. I can leave those. But I think one of the things you need to pay attention to is really the user data. Okay, and that's like the most important thing. One of the most important thing that you have to specify. And I'm going to explain it in the slide. But because we are creating an EC2 instance, we need to add a user data script. So a user data script is like every machine has a user data script. Because think about it, that when we said we were trying to set up an OS, right? We just said we choose an OS already. In this case, we said Linux 2, and then we've said we want to use like a, what do you call it, a particular instance type, right? So that is instance type will have CPU, it will have RAM. But the question is that when the machine comes up, what happens? Ideally, there's like a bootstrap, they call it like, it's like a bootstrap script you can run on the machine, right? So instead of you having to log into the machine and doing that script, you can actually put it as part of creating the machine. And that script is run for you once, when the machine is initialized. Okay. And you see user data because you can use it for so many things. You can use it to more or less like, oh, before this instance, boots up from the beginning, I need to download some things, I need to pull in some files, so that's where it becomes important. So user data is something that we're going to see almost throughout, right? And even as part of your journey, like user data is like really one of the most important part of an EC2 machine, because most machines don't just start ground up. There's usually like a script that has to bootstrap many of the things that the machine needs, right? And because think about it, that if I start a machine, right, and I don't bootstrap it, it means that I have to go back into the machine and I have to install all those things, okay? And that's the use of user data, but we're going to see it as time goes on. I have one that is already here. I'm just going to copy it because I can't be typing it on this call. So I'm just going to paste it here. So what does it say? It says basically whatever you see here. I think this just emphasizes that some of these things you only understand it if you understand Bash to some extent. It means that as time goes on, you also need to try to get comfortable with understanding some things about Bash, like the Bash scripting language. So here it says I'm installing. I'm just doing like an update. I'm installing the HTTP PD server, right? And then I'm also more or less like I'm updating the machine. I am installing the HTTP server is just a web server. So here I'm trying to test a very simple example, right? For me to be able to access a very simple web application is what I'm trying to access here. So systemctl, I'm starting it. I'm starting the web server, and I'm also enabling it so that whenever I reboot, it's automatically started. Okay. So and it says it just prints an h1. So here it echoes an h1 and it posts it into this index.html. So var ww html index index.html, right? Which is like, if you I know for some of you this might be new, but usually for people who host website, there's like always the index.html file, which is like the root page, like more or less like the home page you visit when you go to a website. So we're saying just tell us like it's EC2 welcome page, right? That's the title we want. I think we're good. So we've set up everything that we need. You remember, if you remember, we left many of the things blank, right? So we didn't really specify any of the things. So I think we are good to launch. So I'm just going to launch this one. It's launching. Let's give it some time. So if you also think about it, remember I said allow everyone. Yes, it's spam. It's spam. That's the yes, it's spam. So so that instance is creating. So let me go back to my, let me give it some time to boot. Let me see. So if you go here, you see that the instance is creating. It's here, it's creating. Oh, that was fast. It's running. Yes, but it's still initializing. So let's give it some time. Okay, let's give it some time while it initializes. Maybe that will take me back to what I wanted to discuss next. So while we're waiting for it, we'll go back to it. Let me see. Yes. Yeah, we did. So when you think about it, right? We had a machine. Right now, we requested a machine from the cloud, and then we said we wanted a machine. So the machine is creating right now. But if you remember, there was a place we asked for a key pair. A key pair is basically what you need, right, later to access the machine. Whether you're doing it from a Linux machine or you're doing it from a Windows machine, whatever the machine is, there's always like a room for you to connect back to the machine. Remember, if you have a machine that is somewhere, there are sometimes you need to access the machine. You need to go in, right, and more or less like gain secure access into the machines for you to do administrative work, right? And that's where SSH comes in. The key pair we generated at the beginning is really what we'll use that for. So it's basically a way for you to access your machine, right? Regardless of where you're connected from. Okay. So let's go back and see. And also it's like a protected key. You can't share it with anyone. But let's see. Let me refresh this. Still initializing. Okay. Let's give it some time to initialize. So let's just go into the instance. What is there? Let me see security. Right now, it allows SSH from everywhere. It allows port 80, right? 80, like I said, when you do HTTP, you go to google.com, you type 80. That's really port 80. We'll see some of the popular ports that are out there also. But port 80 is really what you get when you just type HTTP and you do, this is not, HTTPS is 443, but HTTP is really 80. It's a very common port, okay? So when you do this, I think Google will redirect you back to HTTPS, but what I did there was actually HTTP, okay? So if you see what we did here, we said, and don't worry, we're going to explain security group as part of this call, okay? But right now we said, remember for IAM, we had like a policy that was guiding us, right? We said you could do this with a service, you could not do this. That's how EC2 is also, the fact that you can decide who has access into the machine. So yes, that's correct. So if you see in this case, we are saying port 222 is really SSH port, right? If you have to gain secure access into the machine, and 80 is really port 80, really how you access the application from the browser, okay? So our instance is still loading. I don't know, I think it's here. Let me just open this here. Did I just zoom in instead of doing a click? Okay, so let's see if it's still up. Let's see. Okay, so good. So status check 2/2, instance state is running. So meaning the instance right now is running. Okay, we set up an instance and now it's running. So, and then remember we gave it a bootstrap script, right? It gave us a public IP. There's like a private IP here. So what happens if we try to access this one? Let's see. I don't even know if it's going here, right? So it's taking a while to load though. Let me see. It's taking a while. Okay, let me do Control X, Control V. Okay, so one thing you notice is that I did copy it, right? Thank God, like, I'm happy I was actually sharing to you because now it's trying to open HTTPS, right? But HTTPS is really not in the security group, and I'm going to explain security group at some point on this call. But one thing you should notice is that it's trying to open HTTPS, but there's nothing enabled around HTTPS. So I'm just going to take this out and I'm going to do this. So you see that automatically, right? It showed us EC2 welcome page, right? And that's the role of the bootstrap script. Remember, we gave it a script. The script is just saying that when you are launching this machine, right, do the set of script, and that script can be anything. It can be downloading from the internet. It could be pulling files down, anything that needs to do. Just think about it like if you have to bootstrap a machine, you need like an EC2 user data, and you have to put that in, okay? So one thing you should also notice about this EC2 instance right now, it's available here. Remember, if you check the way I'm accessing it, so you have to take note of that, just in case for some of you wants to practice. If I do control, if I cut it and I paste it, you see I'm using HTTP, okay, not HTTPS. Right now, the machine is not configured to serve HTTPS traffic. It's just HTTP. So when I click on it, it's going to show me this. And basically that comes from the user data that we specified. If you notice, there was a place I placed a user data, right? What else can we see about this machine? So this is like a machine now. It's out there, it's running. So if anyone who has this IP, you click on it, you should be able to view it. What else? Right now, the instance state is running, right? So it's actually running. But there are other things I can do. I can actually go into the instance. I can stop it. What do you think stopping does? Stopping is basically, if you remember, I explained to you that compute is charged if you are using them, right? So for example, you have this instance running, but now you want to pause it, right? So that you don't pay money. Instead of you terminating it or removing it, you can pause it. Pausing is a way for you to more or less like be like, I don't want to incur cost, but I still need the machine, right? So one option for you to do is just to stop it. Okay, stop. So I'm just going to stop the instance. Okay, yeah, and there's a place I'm going to with this. So let's give it some time to stop. So we're going to stop. It's stopping. So let's give it some time. It's going to stop. Let me refresh. Let me see if I can still access it. This is now spinning. It's no longer loading. So it's spinning now, but it's no longer loading. So like it's no longer loading, meaning it's not showing the. If you see my browser up here, it's just loading. It's not really showing anything. Okay, because it stopped. The machine has been stopped, right? So what it means is that the machine has been stopped. If I go back here, it's just going to spin forever, right? Yeah, it said the site cannot be reached. Okay. So what it means is that what if we restart it? So we stopped it. Right now, you'll not be billed. Remember, because you stopped the machine, so you're not going to be billed, right? But what if we wanted to start it again, right? And now we're going to incur cost. Once we start it and it starts running, remember EC2 is built based on the time it is running. So if it's not running, you're not going to incur any cost. But if it's running, you will incur cost. Okay. So now it's depending. I'm going to give it some time for it to start up again. Let me be refreshing this and see what will happen. Let's see. So I'm refreshing. It's still not taking the request yet. So it looks like it's still in the process of starting, right? So let's go back here and refresh. It's initialized. You have to keep your eye on the status check. I think there's an initializing phase here that is happening. So let's keep refreshing this. It still hasn't. Okay, let's do refresh. Good. Okay, let me click on the instance. So one thing you quickly notice is that this is HTTP, right? If you look at this IP here, this is 32.210.12.131. Did you notice that? But I stopped the machine and I started it again. All of a sudden, if you see, the IP address has changed. Okay, the IP address has changed. So now it's 18.236.82.28. So what it means is that even if I refresh this forever, I'm not going to see the URL again. Why? Because every time you stop and start a machine, the public IP will change. Okay, the public IP will change. So the public IP is going to change. So in this case, it has changed. So if I was still there, I'm not going to get anything. But if I come back here and I change and I copy this URL, this IP, and I change this one, right? More or less like I do this and I paste it here and I do this like, I don't know why sometimes I wish, yeah. So you see, now it's showing. Okay. So what it means is that every time, take note, every time you stop and start a machine, the public IP address will change. It's in the slide. I'm going to share it, but I'm just showing you practical. It's going to change, but the private IP is not going to change. And we're going to see what the private IP is. Public IP is really what anyone can use to access it over the internet, right? Private IP is something that is unique within the account. Okay, so in this case, you can see, the IP did change. So we've seen stopping, we've seen like stopping it, starting it again. If you go to instance state, also you can terminate the instance, but right now I can't terminate it because I still want to use it to show you some other things. Okay, so you can terminate the instance, you can reboot it, and then you can stop it. Those are the things I really want you to take note of. Just know that right now it's running and it's not going to charge us. It's not going to. What do you call it? It's not going to. We're not going to be billed because we are running under the free tier. Okay, we're running under the free tier. But again, we're also not going to terminate it because we need the machine for other things. So let's go back to the slide. So what have you seen? We created a machine, and all of a sudden, we were able to see EC2 welcome page, right? We were able to see EC2 welcome page, and that's because we supplied a user data script. Okay, user data script is something that it's going to be different. I don't know, your own need of, like, you want to start a machine, what you need to put in your user data script will be different from mine, my own requirement. So it's not a fixed script, it's any kind of script, okay, that you want to put in there. Just know that that script is run once when the machine is booting up, right? And then you can also, and that script runs as a sudo user. Okay, so you don't really need to do sudo, give sudo permissions for that script. That script runs really as sudo. Power user access is what that script is using. Okay, so that is clear. What else is in the, let's continue. So we've seen, now you have a machine, right? A machine is running, but again, in most times, right, the machine is there. Someone can see it in the UI. So it means that it means that someone from somewhere can access the URL, right? See the browser. But that's not all, because you, who is the cloud person, remember, we on this call here are trying to be the guy who is like almost like at the, I don't know how to put it, but we are, there's, they usually say there's front end, there is back end, and it is like infra. So we are like at the last level on that flow, right? So it means that sometimes you need to go into this machine. You need to more or less like go in there. You need to pretty much troubleshoot, check if something is working as expected and all that. And that's where you now need to SSH into the machine, right? And we can demo that quickly. So the first example I'm going to show you here is on Linux. I'll show you Linux and then we'll try to do it on Windows. Because I'm running the Windows machine, I don't have Linux installed, right? I don't have Linux. There's no way I'm going to show you Linux on my local machine, but that's where Cloud Shell comes in. I think, yeah, I'm not sure a lot of people do this, but I'm showing you now. So if I go into my other accounts and I do this and I go here, like I go to Cloud Shell. Let me look for, okay, Cloud Shell is already open here. So remember, this machine is launched in US West 2, right? And the Cloud Shell is here, right? I think I started a shell, okay? So I'm just going to do this. So this is Linux example of trying to gain access into that machine. So if I check uname, I'm in a Linux machine, which is good because I don't need to install Linux machine on my local Windows for me to show you this. It's going to take time, right? But yes, why not use Cloud Shell to do that? Okay. So if you were using a Linux machine or you were using like a Mac machine, this is going to work for you. Okay, this example is going to work for you. So what am I going to do? I need to basically connect to this machine. So if I go back to the machine, I'll look for the private IP here, right? And then I probably want to do I want to do SSH. I think EC2 user is what I need to use. EC2 user. Then I'll give you the private IP. Let's see. Not even sure where this is trying to connect from basically, but I just want to be sure I'm in the right place. I am. Okay. Okay. So what I need to also do is that I need to basically, I think I need to give you the file. Like, there should be some place here. So first of all, let me upload the file. Let me go to, I'm going to upload this file. Okay. So it's uploading my PEM file. Remember when we did like a keep here, right? When we did a keep here, right? When we downloaded the key, when we set up the machine, there was room for us to download the keep here, right? Which we did, and I stored it. So now it showed me that it has saved it as home Cloud Shell user. Okay, so I'm going to list it. So ls /home/cloud Cloud Shell. But this can also be your Linux machine or Mac machine. It just depends on where you store the file, right? So the keep here that you downloaded from creating the machine, it depends on where you stored it. You can always make reference to it. So right now it's here. So I probably need to do this and then do, now I want to give it like a keep here file. So give it, let me give it like where I want to connect to, this one, and do / my web server and then connect to EC2 user, this one, this one. I'm not even sure why it's not even trying to make connection at all. Like, it's not even attempting. Something is not right. Let's see, action. Environment. But I can't from everywhere. Like, it's not even trying to connect. Mhm. And I'm not entirely sure why it's not even making move. Like, it should even tell me it's having issues. Let me go back to the instance. Let's see. Is this not a private IP? Is there something wrong? 72122. I'm actually allowing everyone, right? So it should work. I don't know why it's not even trying to do that. Okay. I'll come back to this. Let me see if it's peculiar to my Linux environment. I'll come back to it. Let me go to PowerShell. So let me try for Windows. One must, at least I should be able to connect from one. So let me go back to Windows PowerShell. That's what you get when you do these things live, right? Live on the call. So I'm just going to do, sorry, SSH. Let me see. I think, so where is the path to that file again? So now in this case, I want to do, okay, you guys are not even seeing my screen. So let me bring that screen over. Sorry, so I'm back to Windows. I'm trying to test something on Windows. I don't know why that one is. What I was trying to show you before was like the Linux example, right? But I didn't want to use Linux on my Windows machine. I wanted to use what was already in the cloud. Check the IP address you use. The IP is fine. Like I can see the IP is correct. It's this IP. So I'm not entirely sure. It's not even, at least it should even tell me like it's not trying to connect. It should even tell me, but it's not even complaining. It's not saying anything. Let's see. Did I give it a VPC? I don't know. Whatever. Like to see security group. Oh, it's possible that it doesn't really. It's okay. I think I probably know the problem. I think I know the problem. Let me see. I think I know the problem. That's why I always tell you, you need to build these fundamentals. Okay. Environment. I think I know the problem. Let me even see which is security group this guy is using. It's using, what's the name of the security group? Launch Wizard 1. Okay, so I can possibly give it this guy and this guy. And then let's give it some time. So it did create a new environment. I'm within the VPC now. Let me try something else. So let's now try the command that we're trying to do before. Let's see. This, I think, is this one, the SSH command. I think it's this one, right? Okay, so let's do this one. Now, this is actually what we're supposed to get. This is the step we're supposed to be, okay? Like I mentioned, if you were on Mac or on you were on Windows, once you download the keep here, right, you don't need to do all these things that I'm doing because you are on Mac or Windows, okay? What you just need to do is that specify the file, the path to the keep here, right? And then say you want to connect to EC2 user at a particular IP address. That's basically what you are doing. So EC2 user at the private IP address of the machine. So it's here, private IP address, okay? But in my own case, right, we get a warning. It says that permission, blah, blah, blah. So the permission on the file is currently 0644. We need to change that permission, okay? So there is a command to do, and I think I'll just do, I think I already had the command here. So I'm just going to run a command, basically saying that that file is too permissive, okay? So I'm just going to close the command, the permission a bit, and I'm going to try the SSH command again once more. Right now I'm in. So if you see now that I'm inside the command, I'm inside that account right now. So if you see that where I was before, I was here, but now I'm actually inside the machine. Okay, and how you know I'm inside the machine is that, remember, there was like an EC2 file, EC2 key pair that we created, right? Maybe we can go and check that file and see what is inside. If you remember, it's in a directory called this directory. So let's do cat this. Sorry, I didn't specify that very well. So can you see? If you can see that, please let me know, so that you know that we're actually inside the machine. So what I did was to do a simple cat. Cat is just like I'm trying to see the content of the file. So I think this is where people tell you that you need some Linux skill, okay? You need some basic like Linux skill for you to move around. Especially if you create, if you create Windows operating system, right? You should be able to interact with Windows. But in this case, we are working with Linux. So if you notice, I'm already inside that machine. So I think I zoomed in a bit, but now I can't even zoom out as much as I want. But can you guys see it? Is it clear? Or let me just clear the page, and then so you know that we're actually in the machine. We are, because what I did right now was to cut the content of www.html index.html, and you can see it tells us the EC2 welcome page. So whatever you see here is actually that content. So we are not in Cloud Shell anymore. We are now in the EC2 machine, right? And we can basically exit. So now we've closed the connection. We're back to our original machine, right? So this is how to connect from Linux to that machine. Try this command also. So you see that it's a human error. It wasn't the application that was wrong, okay? So even here, we were trying to connect. We were trying to do SSH is allowed from everywhere. But the problem also at this stage is that we were using the private IP, and that's why we needed to be inside the VPC. Now I understand why that was happening. Because if I go back to that Cloud Shell that was wrong and I do this now, it's going to work. Yeah, it's going to work. Sorry, I think I also need to do chmod. Oh, this thing is yeah, sometimes I think it's just better. Sometimes I even allow you see these experiences, like experience it live on the call, and it becomes very easy. Yeah, so that was the problem actually. So when we remember, I got here and I was trying to access, it wasn't working, and I had to put the guy inside the VPC. But now it's actually working because here I'm now using the public IP. Public IP can be, so it means that if I give you the access key wherever you are, you should be able to access it. Let's try for Windows. Remember, the command we basically need is the question is, where am I? Present working directory. So CD, I don't even know where desktop is, but Windows is kind of like, whenever I'm inside Windows, I feel like, I don't even know, users, Brainyl. Do I have like a desktop here? Oh, yeah, I do. Okay, so if I think that file is called what? It is called my web server.pem. Okay, so it's here. So that's the file, .pem, right? So that's the file. So what we can actually do now, we can actually replay that command. So remember, this was the command we used. SSH, this was the command to that same IP. So let's try it on our Windows machine. But here we are just going to copy this user. We're going to change this user, change the path, because the file is going to be here. So it's going to be here. Let me just copy this one and switch it back. So let's go this way on my local machine, and let's do this. No such file or directory. Oopsie. Why? Okay. To connect from Windows is basically the same thing that I did before, the same thing that I did with Cloud Shell. So to connect with Windows, basically all we needed to do was more or less like use the same command. So SSH-I put the pen key, right? Put the pen key and then use the public IP. I think that's where, honestly, that's really where the issue has been. Use the public IP. The public IP, I was also using the wrong one. The public IP has changed. This is the public IP now, this one. So once we put that, so it's the same command. This command is the same with what we did inside Cloud Shell, right? So, and you do this, and then, yeah, it shows us, and then we can actually cut that same file that we, remember we're inside Linux now. So the same file that we're trying to check, whatever that file is here. We can also replay this command. So we're doing this before. We can always replay this here. Yeah, you can see we're still getting that same file, right? The EC2 welcome page. So it means that from Windows, we're actually back into the machine, right? So this is why I feel that sometimes you need to practice this thing. Remember, sometimes I do these things live on the call, right? I do these things live on the call. So sometimes it's easy for you to, because he restarted the instance. So I restarted the instance, the IP address changed. That was number one. Secondly, when I started, I was putting the private IP instead of using the public IP. Remember, when you're outside the account, there's no way you can use the private IP address. And it's good we are learning this in life, but it's something I'm going to teach you. But it's good we are seeing the problem, because this is the problem actually. The thing is that if you are outside of the account, there's no way you can use the private IP address to do the communication, right? But here I was trying to do that, and I was putting the private IP address. It's not going to work. It's never going to work, okay? Because my local machine is very different from the account. So I'm supposed to use my public IP. That's number one. But again, honestly, in terms of like the security group, it was set up correctly. Everything was supposed to work right off the box. So this is human error. It is me here using the wrong IP address, number one. And then I was also using the IP address that was, when I refreshed the page, I was supposed to now use the right public IP address, but I was also using the wrong one. So yeah, some of these things are things, but it's good because you are seeing it live on the call. Like, you are seeing it happen. These are the things this is like, it's going to be like this. This is like when you start working with these things, these are some of the things you'll be troubleshooting, right? So these are some of the things you are going to be troubleshooting. It's just that sometimes it begins to question, oh, are you doing something right? But I just knew that it was the problem with the local, what I was doing local. It wasn't like in the account. The account was set up correctly. Okay, so we're fine. So what it means is that we've been able to, like I told you, everything we did in Cloud Shell would work in Mac. We're only doing this in Windows. So in Windows, you just need to download the file, and then when you do SSH-I, put the file name, right, and then put EC2 user at the public IP, okay, the public IP of the machine, and then connect. And then we can also do CAT, like we're just trying to fetch the file out, and then we are seeing the file, the same EC2 welcome page that we are seeing here. Okay, now let's talk about security groups. Remember everything that we've been doing since, right? I could connect from my local machine, but what is powering that? Really, that's security groups. Okay, this one I need you to pay attention to this slide. So if you see the fact that I could connect from my local machine, right, I could also connect from two different patterns inside of the machine. So I could connect from a Cloud Shell that was public versus a Cloud Shell that was inside a VPC. Right now, you don't need to stress yourself about VPC. Just know that the one that was inside the VPC was inside the private network, while the one that I just created was like something also that was anywhere around, like anywhere, right? It's just like another environment that is like my local environment. Notice how I was able to connect, right? Because there was a rule app allowing it, okay? So what is security group? Security group is like a firewall before the machine. So the EC2 machine that we're talking about is a physical instance, but before you get to it, there is like a firewall. And that firewall is what is called security group. It's basically a more or less like a security layer that tells you if you can get into the machine. Remember, IAM is about what access you have in the account is different. In an EC2 machine, there's a concept of a security group, and the security group is like a firewall at the ANI level. So it means that the security is outside of the EC2, right? You have to pass that security check before you can actually get to the EC2 machine. So, and what does it mean? It means that in the rule itself, there is only allow statement. There's no deny. Remember, for IAM, there was the concept of allow and deny, but for security group, you can only specify allow. Like allow meaning, yes, who are you allowing, right? There's no place to say who are you denying, because why? It is a stateful, it's stateful, meaning if you allow the person to go in, the person will be allowed to go out, okay? Because when you send a request, you also need to get response. So security groups are stateful. They can allow you, basically specify only allow, but that allow also allows the more or less like the outbound traffic. So inbound, once you allow inbound, right, the outbound traffic is also allowed, and that's why it's called a stateful. It's stateful. It's stateful in terms of security. So by default, inbound is blocked. So what it means is that if you do not specify an inbound rule, it is blocked. But by default, all outbound traffic is allowed. Okay. And stateful, like I said, once applied, applies both ways. Meaning, once you're allowed to go into the machine, right, you are allowed to receive your outgoing connection. Okay. And then there's something I also mentioned here, the fact that you can attach one single security group to multiple EC2 instances. Okay, it's not one for one. One security group can be attached to multiple instances, and also you can attach multiple security groups to a single instance, right? So it can have multiple instances. And then security group can actually reference other security group. But just so you know, like a security group can actually make reference to a security group. Okay. So let's go back. I really need to show you this. I need to show you example of this. And this is where we end the call for today. I think it's good. I really like what we saw today. You can see that some of the things we discovered today, there are things that if you learn it in a particular way, right? I know there are resources out there that can make you learn these things, but sometimes if you learn it, right, and you don't go through some of these, I call them mistakes or some of these nuances, right, you won't perfect it. You will not understand these things. So sometimes it's good for you to see all these little nuances, and that's actually where the strength comes. Okay, it's not just. Sometimes people are used to seeing good example. Oh, this is how it works. But have you ever seen an example where it doesn't work and you have to figure out why it is not working? That's an example. That's exactly what we saw on the call. Okay, so let's go back to our security groups. Remember right now for this instance, this particular instance, if you go to security, so there's a security tab, right? So if you go to security, there's like a security group attached to it. It is called Launch Wizard 1, okay? So if you go to Launch Wizard 1, we'll now see all the security groups that are attached. So you see there's inbound. Inbound is really what is allowed to come in, right? Outbound in this case is, allow traffic. In this case, we're allowing every traffic to go out, right? For inbound rule, we are saying SSH from everywhere, right? And that's why if I go here, I can always redo the command that I did before. So it's still going to work. Like if I run the SSH again, it's still going to work. It's still going to work. Why? It's because right now I'm allowing everyone to connect. Wherever you are, you can connect. In as much as you have this the keypem, which is .pem file, you'll be able to connect. But what if I go back and edit this rule? And I just delete it. Like I don't want anyone to be able to access it, regardless of where you are, and I save the rules. What do you think will happen if I go back here and I try to run the command again? So I'm just going to exit. Where is it? I can't even feel my console. What's happening? Did it just end the connection on me or what? I don't know. Okay, so let's try it again. So this time I'm just going to copy this command. Okay, I think it's actually, yeah, because I was no longer allowed to connect. Yeah, it disconnected me. So let's try it again. Remember, I've taken out the inbound rule. Now there's no inbound rule. Okay, there is no inbound rule. So let me try again this time. So the same command that worked before, if I try it again, it's going to stay here forever. It's not going to work because what I've done is I've silenced that part where you can connect. So right now you won't be able to connect again. You won't be able to connect. But again, if you look at the component of this inbound rule and I add a rule, and there's really where you can choose which ports can access. So you see there are so many ports. Yeah, it means that you can actually streamline the ports that you want, right? The port the person will connect from. Remember, when you SSH, that's port 22, right? And then you can also specify the port range. For example, you can specify anywhere IPv4, anywhere IPv6, or you can even give it a specific IP address, right? And in this case, you can also specify things. But let's go back to our example. If you notice, yeah, connection timeout. So usually one thing that is significant about security groups is that when there is a rule that won't allow you, many of the errors comes out as connection timeout, really. So you see it as a connection timeout. In this case, it's timing out because you can't, there's no security group that allows you in. But what if we go back and fix and we said we wanted all SSH traffic, right? So TCP port 22 source anywhere, it's a very normally nobody specifies anywhere. Like there is nowhere, it's bad, it's bad practice. But for this test, it's okay. So we are saying, you can give it a description and say allow SSH access, right? So and then we can save this. So now we've allowed it. So it means that there's a firewall before the machine. And now because we have allowed it, once we go back and we do that, it's going to work this time. So yeah, it's working. Okay. So basically that's just the SSH. The only thing you need to basically understand about security groups is the fact that if you go back to the document, I said it's stateful, meaning once you're allowed in, you're allowed out. Okay. So it's stateful. It knows if you have access to go in, you can also allow you out. And then you can attach one to multiple instance, and you can also attach multiple SGs to a single instance. So it will just take all the rules from all the SGs, okay? And then security groups can reference other security groups. So like I was mentioning, if I actually go here and I created a new inbound rule, for example, and I said TCP on port 400, whatever the port is, I can say custom, I think here, where am I even? Yeah, I can say custom, yeah, and then this way I can do SG. So I can actually give it a security group, okay? So I can say another security group is allowed to access this machine. So whatever that security group is attached, right, would be able to access this machine. But don't worry, we'll discuss that's like advanced stuff. Let's not bother about it. And then we can save the rule and that'll be it. So what have we seen? Honestly, today has been one, I wasn't expecting it to be this, but the nuances was good because it actually exposes some things that you see on the day-to-day. Honestly, people think, oh, it's going to be, yes, it is smooth. But sometimes what we shared when we're going through that challenge is some of the peculiar things you see. Like sometimes something you feel is not working as expected, and you need to find your way around. And honestly, that's how you master AWS. It's not by watching the video or watching me, right? It's by doing these things yourself. Because if you try it from your local machine, it probably might not work if you use the wrong IP and all that. But if you don't try it, you think, oh, I know it because he said it. But until you do it yourself, that's when you know that, oh, okay, maybe I didn't get the concept correctly. Because just using the wrong IP you know, can mean you can't. It can actually lead you not to be able to access the machine, and you'll be thinking it's supposed to be simple, like I should. But you need to know that if you're accessing it from the outside, it has to be the public IP. Okay, because we've not discussed the concept of VPC just yet, so we'll get there when the time comes. Honestly, this class has been long for today, so there's a lot. There's still more, but I'm going to stop it here because I don't want the video to be too long. Okay.